just to recap, you would have learned this in year 7, but I just want to go through this with you again. The word polygon is derived from the word or part of the word poly, and that means many. So a polygon has many straight sides. It's the general name for any straight-sided enclosed shape. So that's the big umbrella name, a polygon. But each polygon has a special name depending on the number of its sides. So if it has 3 sides, we know it is a triangle. This is not going to work very well. Let's try typing it. A triangle. Okay, if it's a 4-sided shape, it is a quadrilateral. Let's check the spelling of that, please. 5-side is a pentagon. A 6-side is a hexagon. A 7-sided shape, some people get confused, this is a heptagon. An 8-sided shape is an octagon. A 9-sided shape is a nonagon. And a 10-sided shape is a decagon. Okay, so they are the shapes. Let's just make it look nice. So they are all the names of all the shapes depending on how many sides they have. Please note at the bottom here, if it says, if the sides of the polygon are all equal to each other, then it's described as a regular shape. So it would be a regular heptagon or a regular octagon, etc. Within the triangles and quadrilaterals, there are special names for certain shapes, but these have been covered. So recap, area and perimeter. The perimeter of the shape is, I hear you all cry, the distance around the outside. So to calculate the perimeter, you add each side of the shape together. The units will be the units for length, which for example could be centimeters, millimeters, meters, kilometers, etc., etc. Area. You should have covered some area in the past. So the area of the shape is the space inside it. So the units will always be square units. So for example, centimeter squared, millimeter squared, etc. These ones you should remember. So area of a square, if this side was A, it would be A squared. A times A multiplied by A. For a rectangle, we have the length times the width. So whatever the length is, you multiply the width to find the area of the rectangle. And the area of a triangle, again, this is one that's quite commonly forgotten, but the area of a triangle is the base times the height, base multiplied by height, divided by 2. Now, I have said here it's important that the height must be the perpendicular height from the base. So what that means is that this height here meets the base at 90 degrees. Okay? Often in a question, they will add additional information, so they will trick you by giving you these measurements here, but you must always make sure you're using the height and the base only. Do not assume that if they've given you extra numbers, that you have to involve them in the calculation. Okay, area of a parallelogram. You may or may not have done this before, but I just want to go through this with you. So a parallelogram is essentially a wonky rectangle. So it's been pushed to its side. We know that the area of a rectangle is length times width, but obviously for a parallelogram, we haven't really got a length and a width because it's been tilted. But the area formula is very similar to it. The area of a parallelogram is the length multiplied by not the width but the perpendicular height. So perpendicular height. Now notice it's this measurement here, so it makes 90 degrees with the length. Again, they may well give you this measurement here or this measurement here. So do not fall into the trap of multiplying this length by this length, that would be incorrect. It's always the length times the perpendicular height. So if we were asked to find the area of these two, it would just be 8 multiplied by 6, which is 48 centimeters squared. This one is 9 multiplied by 11. Notice this one, they happen to have labelled the 11 meters outside the shape, but it's showing you that it's this measurement here. So that's 9 multiplied by 11, so that's 99 meters squared. The other shape I want to look at is a trapezium. So you probably have not looked at this before. So a trapezium is a quadrilateral with one pair of parallel sides. So in this shape, you can see they're parallel. In this one, you can see they're parallel. So the formula to find the area of a trapezium is A plus B divided by 2, and then that answer is then multiplied by the height. Now, I have a diagram here to explain what A and B are. So A is one of the parallel sides, B would be the other, and then the height, H, is the distance in between those two. Okay, it has nothing to do with the slopey sides. In this example, because this has been cut off, because this shape is just vertically up and down anyway, then that does represent the height. And then A and B, I happen to have labelled them the other way around just to indicate that it doesn't matter which one's which. The A and the B can be interchanged. So, using that rule, we're going to find the area of these shapes. So we've got A plus B. So in this shape, the A and the B would be these two. So we would have 2.3 plus 7.9. And we would divide that by 2. And now we would multiply by the height. So the height, you've got two other numbers. Do we need both of those other numbers? No. This is the only one that we need now. The 4.9 is irrelevant to us in this instance. So we would multiply that answer by 4.6. So let us do that calculation. So 2.3 plus 7.9, and then I'm going to divide that answer by 2 and multiply it by 4.6. You can see that because I've shown my step of working here, I don't need to show each step of calculation. And that's not very helpful, so we'll press the SD button and we get 23.46, and this case would be meters squared. For this one, the A and the B are 3.2 plus 9. Divide that by 2, and we multiply the distance in between them, which in this case is 6. This time I'm going to set it out a little bit differently. So I'm going to open up a bracket and I'm going to put a fraction in there. So we've got 3.2 plus 9 on the top and 2 on the bottom, and then close my bracket, and then we're going to multiply that by 6. Again, SD to give us decimal value, so we have 36.6 centimeters squared.